start for the last webinar for this year. In December, we decided not to make one based on the very short time. So I'm happy that we have some attendances, and we start with the webinar from the idea to inspection. How to plan a successful machine vision project. So it depends on how much experience everybody has. Of course, some of the ideas are, or things which we discussed today might be not so totally new, but I think sometimes during the process of generating some solutions, one forgets some of the things which are important. So the main pillars of a machine vision system, of course, at the end is the brain, of course, but as important as the brain are the eyes. That means the cameras, and of course the lens and the light is also very important. On the way of the light, sometimes one forgets to have the option of a filter. Filter makes life easier in many cases. Of course, in most cases, people think about filters only in software, but as for every measurement system, if you can optimize the signal on its path to the receiver, it's always better to improve the signal at the very beginning. So the filter is normally, the optical filter, let's say it this way, is normally the first way to operate. Even if we put it on the fifth position here today.
You are not sharing the screen.
Oh,
in case
really?
You were, yeah.
Okay, then I go back. I thought I shared. I forgot it. Sorry. Activate. Share. No. I see this is a new version. Here. Here we are. So now for everybody. Oh, now everybody can see it. Sorry. Of course, I see the presentation anyway here. And yes. So let's start with the presentation again. How to plan a successful machine vision project. I think I told it already. And of course, here we have the our five pillars, how to make it. And I just arrived point 5. It's of course it's the front line of the information. That means if you optimize the image, as I told it before it arrives in the memory, it's better to optimize it here in the filter area. And finally, what also many people forget, if they make a machine vision solution, to have the right lens or a good lens, the best fitting lens for the solution, makes life easier. Of course, one can do a lot. One can optimize signals if they arrive finally in the memory of the software. So we have, as I said, the brain of everything is the software, and of course the software has a lot of filters, also distortion filters to optimize or correct distortions from lenses. But first of all, not all distortions can be corrected. It can be guessed somehow, I like to say. And the thing is, if the image quality based on contrast is not so good because maybe the light was not the optimal selection, or or the combination of light and filter, it's exactly the same problem finally. You have a bad signal in your main memory, and if you have a bad signal or not a good signal, however you want to name it, finally, it's really difficult to, even with the best software, to generate a stable working machine. And of course, if you have selected the right filter, the lens, and the light, the camera is also important. Meanwhile, cameras differ not so much. Of course, there is a wide variety of cameras and camera technology, but if you use 2D cameras, the number of manufacturers of sensors are limited, and therefore you can get from different manufacturers different cameras, but in many cases with the same sensor. So it's more a kind of taste which manufacturer fits. Anyway, with the EyeVision software, with the brain or with the software at its heart, it's necessary that the software can support the camera. More important is that the software can support the different interfaces which are used to connect the camera to the system. And the interfaces are mainly today more important based on speed. If you have an average application which you have in mind, with let's say up to 20 parts per second, normally we suggest gigabit Ethernet, even with a higher speed, but with most requirements of standard machines with, let's say, 15 parts or even 20 parts per second, gigabit Ethernet is a no-brainer. You can use it and it works. You can also use USB. It has some limitations. One has to think about it. If the system is close to the machine vision system is very close to the application, USB 3 is also very good. If you have multiple cameras or so, maybe you have to think about does the system support so many ports for the USB cameras. And finally, if you have very high-speed systems, either you need not a gigabit Ethernet, you could use a 10 gig E. Most of the manufacturers now allow have 10 gig E cameras, or if it's faster, you can use QuackExpress or the now more or less outdated interface, camera link interface. So finally, for you as a user, it's really important. Oh, I see there is someone in the entrance. So sorry, so for you as a user, first of all, you have to think about what is the speed of my system? How many cameras do I have to connect to the system? And based on that, you can select, should I use USB, GigE, QuackExpress, or Camera Link? Of course, there are still analog cameras out there which could be used, but for new systems, we recommend normally gigabit Ethernet or USB 3. And as long as the bandwidth is enough, based on the seamless connection to modern computers, we recommend to use gigabit Ethernet. Which manufacturer would be the best? It depends on, as I just tried to explain, on the taste. The more important is what kind of camera, what kind of sensor do I need? So if you have more endless material, that means foils, plastic, metal, or even fabric, we recommend normally, and it is in the production line, we recommend 1D night scan cameras. They have a lot of advantages, and of course the software has to support it. But if you have endless material, you don't have to think about connecting the captured images together to one big image, because with line scan cameras, you can add the incoming lines to one big image as long as you want. And of course, to do it, yes, 1 second. Who sent me a question? Yes. My experience is that network cards are much more stable due to jumbo frames. Yes, there was the recommendation about the network boards for gigabit Ethernet, and of course we can we suggest to use Intel network cards, where the Intel chipsets is really good. Meanwhile, we found out that some others are also working, but if there's no reason not to use Intel cards, we recommend to use Intel cards, or let's say boards with Intel chipset on it. That's correct. Yes, also for line scan cameras, to come back to the original thing. Also for line scan cameras, normally GigE is fast enough for the average line scan application, up to 60,000 lines per second, depending on the number of pixels the line scan camera has. Gigabit Ethernet connection is still fast enough. And of course, the good thing is you can get a lot of GigE boards, which you can add to your PC easily over PCI Express if you have multiple cameras, to allow to use multiple cameras at the same PC, which is really nice if the bandwidth is in question, or if you have multiple cameras, like let's say 10, 12 or whatever cameras. You could use, if you don't use 10 GigE cameras, you could use a 10 GigE PCI bus board with, for example, an Intel chipset, and a switch with, let's say, 8 GigE cameras and 8 whatever GigE ports, where you can add different cameras. So it's very easy to connect multiple cameras to one PC. This setup, this is a bandwidth problem, independent on the sensors you want to use. Of course, the nice thing is, if you have sensors which support the GigE, it's mostly the GigE interface. We have to do the specification. Yeah, it's very easy to attach the cameras to the hardware. And depending on, as I said, for endless material, woven, non-woven, any kind of metal, plastic, or whatever, we recommend normally line scan cameras. It's easy. You have one line and it's easy to illuminate it. It has a lot of advantages if the software supports it, of course. Whatever I told about the light lens and filter, it also belongs to the line scan cameras, as it belongs to the 2D gray or color cameras. Whatever from whatever manufacturer you want to use, normally you have simply to check, is the resolution fits the resolution to my needs. Normally, if you want to measure something, it depends on the software. Either you select the camera with the fitting resolution. That means you have a resolution which allows you to get, you have a 3x better resolution as you want to measure. If you want to measure, if you only want, sorry, I have to add another participant. If you want to measure, normally higher resolution allows you to measure very exact, except if the camera allows you to do subpixeling. Subpixeling is a method which generates an accuracy beyond below of the pixel resolution, based on the knowledge that a signal never goes from one pixel to the other pixel, from one gray level to the other. so you can calculate where the edge is. If you have a front light situation, normally you can, if the software supports it, like the EyeVision software does support, and of course some others. If you have a front light situation, normally you can use a pixel resolution and generate a 3 times higher measurement resolution based on this proximity of the pixels. If you have a backlight situation, normally you can reach a 8 times higher resolution than the pixel resolution is. The pixel resolution, you use your field of view and divide it to the number of pixels you have. And this is the pixel resolution, the accuracy of 1 pixel. And if you have a front light illumination, means the light is on the same side as the camera, you can do it 3 times better. If the light is on the opposite of the camera, you normally can reach 8 times better resolution if you have a subpixel algorithm for measurement. So these are the constraints for the cameras. Resolution is always good. But if we talk about resolution, resolution means not only the camera, it's also the lens. Many people forget that the lens has also a wavelength constraint. And if you buy a 5-megapixel corrected lens, it makes no sense to buy a 12-megapixel camera. Or vice versa, if you buy a 12-megapixel camera, you should buy also a lens which allows you to pass the wavelengths with the same resolution, else you get only what the lens can do. So that's something what people forget when they select their components for measurement applications. They buy a high-resolution camera with 12 megapixel, buys of course the cheaper lens for 5 megapixel because 5 megapixel lenses are cheaper. And finally, they wonder why their measurement resolution is in the range of the 5 megapixel and not of the 12 megapixel camera, simply because of the lens. So lens is an important part of the machine vision application, as important as the camera. And let's follow up to the 3D sensors. If you want to do 3D, this is related. Let's say machine vision started at the beginning with 2D, and later the 1D cameras, line scan cameras, approached the market. And I think about 15 years ago, the first available, price-wise available 3D sensors were in the market. And with this, the 3D application started. Today, of course, there are not as many 3D cameras in the market as 2D cameras, but there's a wide range of 3D cameras. Especially for 3D, it's really important to think about what one wants to do, what is especially the resolution, and especially also the other constraints about the surface of the part to select the right sensor for the right application. It's not as easy as a 2D sensor because each sensor has some constraints about surface or surrounding light and which are much more difficult than the 2D. So we are happy if you have this application, you can simply ask us which sensor might be really, or what we could suggest, which 3D sensor is working. If you only need a very rough idea of an object, maybe you want to sort some parcels, single parcels on a belt, you could use nearly every one-shot 3D sensor from time of flight to stereo vision or some others. But if you have some constraints about recognizing the parts and maybe the parts are very close together and so on, it's more difficult to select the right sensor. and therefore it's not so easy to give you an answer what might fit to the needs. So simply feel free to send us a question about your application, and we can help you to with a bunch of sensors which fit for your application, based on the resolution and some other constraints which we recommend for these kind of applications. And of course, beside of the area where what humans can see, we have the thermal cameras and the sphere cameras. These are the cameras on the right and the left side of the spectrum, where human eyes can't see, but many applications can be solved simply by using this camera, because the contrast, let's say contrast, is there. For example, if you want to decide if a motor is working correct or a PCB is well populated and all the chips are working, you could look with the camera and maybe you see the solder joints and everything, and you can decide, oh yes, it looks very good. But finally, it looks only good. You don't know if the chips are working. A working chip could be seen simply if you use a thermal camera and you see if it's working, it is in the correct temperature range. Thermal cameras generate a contrast image, black and white, or most software, like the EyeVision software, also can colorize it. That means if the temperature is colder, you get a blue image, and if it's hotter, you get a red one. But at the end, it's a contrast which you can use, and the contrast is defined to a temperature value. The same is if you want to check, for example, if there is a hole in a surface, under the surface, you could use a temperature camera. And for many other applications where temperature is key to solve the application, you simply can see the temperature with the thermal cameras. Therefore, thermal cameras are good. And sphere cameras are on the other spectrum. They help you to, for example, detect different kind of objects from different materials, simply because their response is in different wavelengths, which so another attendee in a different wavelength where the camera can see it. So, for example, if you have 3 white powders like sugar and salt and some other, if you use a normal color or gray camera or even a thermal camera, you see only 3 white substances. If you use a sphere camera and of course a fitting light and lens, then you will see different response of that, and you really can decide, okay, the left one is the salt, the center is the sugar, and the third one is maybe any illegal substance which you can detect based on the responded wavelengths. It's like a gray image where you have different gray tones. It's in the different substances generate a different gray value in this additional wavelengths area. So you can also see the difference between coffee beans and maybe similar colored rubber or whatever material, because the response in the response of a coffee bean and rubber material or a wood material in the same color is different based on the material. Even if for the color camera it looks similar, in the sphere area it looks different. And hyperspectral is simply a camera which allows you to have a very wide spectrum over all wavelengths. So you have a lot of choices to get all these responses without changing the cameras. Normally, of course, you could use also a color camera, a thermal camera, and a sphere camera. to do a similar thing, not the same, because the wavelength is the wavelength range of hyperspectral cameras is much better. Also here, if you think about what is the best camera for your application, you are feel free to contact us and give us some questions, and we can tell you which camera might be good or the best one for your application, or maybe which options you have, because of course, hyperspectral is very good, but one of the most expensive cameras. Belongs to the most expensive cameras in the market. There are some 3D sensors which are much more expensive, but hyperspectral camera is in a really high price range, at the average in 12,000 euros, to compare it to, let's say, a simple gray camera, which you get for 200 to 600 euros. So a real difference. If you can do it with the normal camera, it makes no sense to use the hyperspectral. But in some cases, hyperspectral is the right choice, even if it's expensive, because it simply proves that you can make the solution. And then what is really important, beside of all these measurement and matching tools, or some special thermal tools to operate on thermal or hyperspectral images, there is one cross-platform or cross-image technology. Everybody knows it, and it's in all kind of media now. We name it deep learning or artificial intelligence. This tool allows you to solve things which machine vision tries to solve, let's say, since it was invented or became usable, let's say in the early 90s, last century. There were always applications where everybody said, okay, that makes no sense. You cannot do it with machine vision because there's no contrast. Whatever filter you use, whatever camera and so on, you don't have the contrast. And it's really difficult or not doable with standard algorithms like gray image evaluation, if you use an edge detector or whatever. Deep learning works like the human eyes if the network behind of it is well trained. So you can, for example, use it to find scratches. Scratches, for a long time, scratches were on any surface were always really difficult. And every human could see a scratch on a water tap. And many industries, also the automotive industry, said, we have to find the scratches. And everybody said, okay, it's not, you cannot do it stable. You cannot do it for the production run. But with deep learning, you have a tool which allows you to do it not simply, but you can do it simply. Stable, also for the production line, and of course also the classification. So you can do 2D or 3D classification, also based on gray values or 3D values. But of course, if it's really difficult, deep learning is one of the options which can help you. For example, if you have silver fishes on a silver surface, you will not be really successful with a gray image or a color image. If you use a deep learning network which is trained on this kind of application, you simply solve it. If you want to see how it works, I really recommend, and I think everybody gets it after the webinar, you can download our demo version, which is fully functional. And there is the AI tool in some demo projects inside, a lot of demo project. And you can simply look to this object segmentation demo to see what AI can do. And of course, we had also an AI webinar this year or last year, which is still in the net. You can see there how the AI tools are working, but you can do it with your hands on by yourself with the demo version. It's fully functional, and that allows you to see it by yourself how to work with it. And of course, finally, the world is going on and you want to operate on the results of the vision. a robot vision allows you to use the results of the eyes, of the sensors, to do some kind of application like bin picking, palletizing, depalletizing, and all other applications. So the software, of course, is the brain. If the brain has a good image, it also works stable and can do a good solution. Finally, what's really important, or more or less important, is to have the right hardware. That means, of course, you can always take a PC and the camera, but sometimes you have only a small, lightweight application, and then a PC might be too much. So it's always good if you have the option to select, of course, a hardware which allows you, a software which allows you to select the right hardware. Either it's a PC or a smart camera or an embedded system with a Linux on it. Of course, everybody knows the ARM systems nowadays based on on all the smartphones. One example is Android as a Linux version. So it's nice if you have a software which allows you to run on all these different platforms, so you can optimize the hardware which you want to use for the application. If you have a single task application where you want to see how many objects, black and white objects there are, you could use, for example, a smart camera, and therefore you need a software which can run on a fitting hardware like ARM-based smart camera. Most smart cameras today are ARM-based, and on ARM you have, in let's say the majority of all cases, a Linux running in smart cameras. Of course, if you have a smartphone, Linux is the underlying operation. And on x86 platforms, you have the option to choose between Windows or Linux, so that you can select what hardware fits to your needs. Smart camera, embedded platform with a camera, or with a normal camera with GigE interface or USB, or a platform where you can use a MIPI interface. All these different options are available. You can use the fitting hardware for your application, price-wise and from the calculation power. Finally, how to make the solution. Of course, first of all, in the center, as always, you see the image. The image is important. Either it's a 3D, a 2D image, a thermal image, but the important thing is how to make it easy and fast. So one of the key things is, of course, you can say I can program in C++ to make my application. But the question is time to market. How long does it take to program in any programming language, either if it's C or Python or whatever, to realize the solution? Not only, first of all, in the first few, to do the vision task, and then, of course, to have a user interface which allows you to adapt also the parameters and everything. It's not only programming the vision task. The vision task is one important part, but because you have a machine, sometimes you have to adjust the parameters, you have to transfer the information and everything. And then if you start programming, 1/3 of the programming is the vision task, and 2/3 is normally also infrastructure parts. Means how to connect to the machine, either with a direct PLC or a network interface, or I just got a message, but I don't see it. With a network interface, or how to handle the different tools in for the user, for the programmer, for the user, in the machine user. So you have to program all this stuff, and finally, the average time you need to complete all these tasks um, is one of the important timelines you have to think about it. And if you use a ready-made software, like, for example, the EyeVision software, you don't have to program everything of this. Everything is in the software. You have a toolbox for the image capturing, whatever camera you have. Well, we just discussed the line scan, the 2D, 3D, terminal or whatever. You have one tool where you can select the manufacturer, and then you can capture immediately the image. And of course, in the toolbox, you have the different tools, roughly 380. And a few of the tools is, for example, a Python interpreter, which allows you to also do some programming if you need it. But most of the solutions, if you download the demo version of the software and the projects you see, the majority of the parts you don't have to program. You simply drag the tool from the toolbar into the program editor. And finally, if you have finished it, you can run it immediately. Time to market, the program is finished and you can do it. You have all the adjustment tools inside of the software. And you have also, of course, if you want to make a user interface for the end user, you have a lot of options to make buttons and all kind of end user interface, so that you really can generate only with the mouse the complete solution when you finished your machine vision task, even only with the drag and drop of the mouse. I highly recommend that you simply can go download the software and try it by yourself. Of course, you can add all the logo stuff for your solution, or you can run the software also in the background. If you build a machine and you don't want to see the user interface, maybe you want only see, in this case, the 3D image in your machine. So you can run everything in the background, get only the important information in your machine environment, and everything works perfectly there. So you don't have to take care about all of these different tasks, which if you use a programming tool like C++, Python, or whatever, which you have to program. And of course, you find all the communication tools inside. For example, OPC-UR, Profinet, Modbus, and whatever, to connect to the rest, to the environment, to the machine, or to the SCADA system, where you have to send the data. And of course, you have also the direct access to the I/O hardware. If, for example, if you have only a smart camera with maybe some I/Os, you can directly control these I/Os with the graphical interface. So no need to do the programming. And finally, if you think about different other options, or you want to use your own tools, the complete software is a modular system. So you can simply add your tools if you have some already written in C or C++, or maybe Python. You simply can add your tools to the complete environment. That means you don't have to think about how to capture images from the camera, because you can use all the capture tools and the integration of all the camera manufacturers directly. You only have to think about how to access the main memory of where your image information is, and you can operate on that with your tools. Or, of course, in most cases, I would say you find a tool in our toolbox which fits to your application, but we have the option that you can add your own tools into the software, as we have also the option, if all the implemented hardware is not working, there's another hardware which we don't support, we have also the option that you can integrate your own hardware, if it's your own hardware, or the hardware of any other company. But if you have downloaded the software and you look to the list of the all the supported manufacturers, you will see there is everything what you need. And if you find an important manufacturer which we have forgotten, even Chinese or whatever manufacturer, yeah, we add these manufacturers to the software that you have the option to select the camera you want to use. Of course, because it's a complete software, it's modular. If you use the demo version and you see, I need only maybe the 2D tools for matching and maybe the image capture and something, we can optimize also the OEM price for the software because you only have to buy what you need, not the complete package, to optimize it for your needs. Um, for your needs. And as I just mentioned a few seconds ago, of course, we have all these different communication tools inside, and of course, all the interfaces for these. So you can decide to use OPC-UART, Modbus, Ethernet, MQTT, Profinet, Profibus, depends on the hardware of your system, EtherCAT, UMATI, and some others. Of course, we have TCP/IP and UDP, or you have also RS-232. So you can communicate with all kind of applications outside there. And as I just mentioned, you have also the option to add more communication functionality based on the plugins, which allows you to add any kind of protocol to the software and use all the other infrastructure which is available for the camera capturing and image analyzing tool. We have another image analyzing tool. Yes, and of course, finally, if you made your application and you finished, you can generate this kind of user interface based on the GUI builder so that it fits you to your machine. That means you can integrate the result images to your display, to your machine display, so that the user or the end user of your machine doesn't see that the EyeVision software is running in the background. The software is then operating only in the background, and your machine has the option, the option of the vision solution. And finally, I think time to market. Everything is really fast. Simply, if you like to program and you are a really fast programmer, simply try to compare to make a small application and try to do the same application with the EyeVision, simply to see what time to market means and how long it takes to have a similar option to make it the solution. Finally, to give you a short overview, and you will see it also if you download the software, we support all kind of camera manufacturers which are available not only in Europe, also in Asia and North America. We add these lists permanently so that you have always a choice to select all the new technology which is available. And of course, beside of the image capture hardware, you have the choice if you use the EyeVision software to select, for example, small embedded systems like Raspberry Pi or so, where if you want to make a small application and it should be also lightweight and from the price very cheap, or yes, as cheap as possible. Of course, you have the option, for example, to use something like a Raspberry Pi or so with maybe an MIPI camera, so that you have directly a very cheap system which you can integrate in your machine. As you can use a PC and a normal camera, you immediately have an advantage in the price if you do OEM solutions. Or we implemented a lot of smart cameras with an open interface, so that you have the option to use these smart cameras with the EyeVision software together to make your application. If you use a smart camera, which this one here is an example, of course, you don't need any cabinet or anything to where you can store the calculation unit. Everything is integrated here. And of course, the EyeVision software runs inside. So you have the same interface, the same programming experience, and you don't have to think about how to use this camera. The software already runs on it. In this case, this is a standard ARM CPU inside. You get this also with an NXP CPU inside, so that you can run AI, or you can use a smart camera with an NVIDIA CPU inside. You could use also the Baumer camera or the upcoming AVT new smart camera model, which has also an NVIDIA inside, which allows you to make also AI solutions really fast with a smart camera. If you don't need AI, you could use also any kind of camera. But if you want to use the AI, an AI accelerator would be good. And in this case, the NVIDIA, as NVIDIA is a leader in the market for AI, makes it much easier to run AI in the smart cameras. So finally, if to compare it with programming, of course, you need the brain, and the brain should run everywhere. Optimally, you use the brain on the hardware platform which fits to the needs you have for your application. And if you use the EyeVision software, of course, you have the option to use the brain on all these platforms. And of course, a short overview about our current idea of solutions, and what we suggest is normally USB GigE and Co-Express, of course. In some cases, camera link might be also a good option, because some cameras are still only available for this interface. In most cases, you could solve your application either with GigE or USB. And in some special cases where the high speed is mandatory, Co-Express and camera link are the option for the application. So you have the choice. Based on your application, you select the camera, and if the camera needs Co-Express or camera link, you can use also this with the same software. So you don't have to take care about if it works. You have one software which allows you to make this the machine vision solution very easy and fast. A short overview about what kind of resolution, frame rate, and sensor type would be good for your application. As I told you, it's depends on what you want to see, what your application needs. If the application needs a gray camera, so a color camera is not doesn't make sense and needs only computational power, especially if you have if you're intended to use a not so powerful system like a smart camera. Maybe most smart cameras have these ARM CPUs, but are not so high with a high clock rate like let's say smartphones. So you have to think what is the right resolution pixel wise. I just mentioned it. If you want to measure, and if you don't trust in the subpixel idea, you need you need more pixels to define the accurate measurement. So let's say you need 3 pixels to get exactly the resolution you want to have. If you trust in the subpixel frame rate, subpixel accuracy, you could use a lower pixel resolution. We have proof that it works, but it's in your decision what fits best for your needs or on what you trust. That's at the end, it's a question of proofing and trusting. So you can test both with the EyeVision software. And of course, the speed, in many cases, of course, you get cameras nowadays with 60, 120, 150, and 200 frames per second. Frame rate is important, but in most cases, you don't need 200 frames in your PC. In most cases, your machine runs with maybe, let's say, 14 scans per second, or 40 parts per second. Then you need, even if you have a camera with 200 frames, you need only 40 frames. If your machine can only produce 15 parts per second, of course, 200 makes also no sense. It makes sense that you save some time in the image acquisition, and therefore a high-speed camera might be anyway a good idea to use it, because the image is very fast. If you have 200 frames, you need a 200 second to transfer this image to your main memory, and you can use all the other time to operate on the image, but you don't need the bandwidth of the 200 frames per second, which makes it easier to connect to a PC, of course. If you run the camera with 200 frames per second, of course, you have to think about light. If it's only a 200 second shutter speed, that means you need much more light than if you have more time. So it's also a question what fits best to the image capture, and therefore the gray contrast or color contrast in your image. Can you generate so much light that it works with this fast frame rate? Or, of course, you could use also a camera with 60 frames and a high shutter speed. It's exactly the same. If you use a 200 second shutter speed, you need the same light. The difference is if you have a 60 frame camera and use a 200 shutter speed, the image transfer runs with 160 per second. That means until you need more time until the image is in your main memory and you can start with the image processing. Therefore, a higher image speed gives you simply some more calculation time in your main memory in your software than waiting that you get the image. So this is one of the things why frame rate is really also interesting, because you save time. You have more time for the calculation. Let's say there are really not many applications in the world where you need 200 frames per second, which you have to operate on. Let's say the average production line runs today still with 10 parts and less per second. And the high-end production runs like the beverage industry with 40 cans per second, or the fast-running stamping machines with, let's say, 35 parts per second. These are all very fast. These are the fast edge of the production line. Therefore, the advantage in frame rate is mostly how much time do I have to operate on the image. And of course, if you need a color or gray, it depends on what you want to see. If you have to see a color image is a color camera is good. But if you only have to decide between 2 or 3 colors, sometimes you can do it with a gray camera and a filter, which reduces the amount of pixel you have to transfer, and of course the number of the speed of the CPU which operates on it. And of course, if you need 3D, there's no questions you need a 3D camera, a point cloud, which also increases the amount of memory. Point clouds are always bigger than any of the other images. So you have to select based on that the right sensor type. Always, if you have any question in this direction, simply let us know and we can help you to select the right camera for your application. A short overview or idea, smart camera versus embedded system. Of course, smart cameras are nice because you can take it, you can plug it You have a direct connector here on the back side, an industry connector. So it's really easy to integrate it in your machine. You can directly integrate it. You simply power it up and it runs. If you build your own machine and you anyway have to make a housing, sometimes it's a good idea to think about these embedded systems because, of course, smart cameras belong to the more expensive systems because they have this housing and everything inside. So they start normally at, let's say, 1,500 euros and more. And if you use these embedded systems, which are in some cases more powerful than smart cameras, it starts at, let's say, in this case, the Raspberry Pi. You can buy it for 80 euros and BP camera also for 80 or 50 euros or 120, depends on where you buy it. But you have a complete system for 200 euros, which fits to your needs. So the decision what is the best one decides what you need for your application, and can you do the integration or do you need a finished integration, and you don't want to think about housing and everything, then of course the smart cameras are maybe the easier way for you for the integration. At the end, you can run the same software. You need a similar lens in most systems. So most smart cameras have a C-mount attachment for the lens, as most of the other cameras which you can buy. Of course, there are some smart cameras with built-in lens. Then you don't have to buy the lens. Then the smart camera mostly is a little bit more expensive. So at the end, price-wise, there's no advantage. Of course, the lens here you have to buy separately, but if you compare the two systems, you compare it to the point of the lens, and then the embedded system is normally always the cheaper one. As I just said at the very beginning, light is really important. You have to think about, do you need a gray camera, a color camera, or a 3D camera, a thermal camera, if it's infrared thermal, or if you need a sphere camera, then it's more on this side, or you need a hyperspectral camera, and you see here this wavelengths. So you have to think, what is my application? Therefore, you first of all select also the light. Also, if you have a thermal camera and you don't have a an object which distributes the thermal heat, like an engine or any production line, any electronic circuit, or even if you watch a human, then you don't need a special heat source. If you don't have this, then you have to think about the light. You need a heat source that the camera can see something. The camera can see only temperature, and in some cases also, as if you have a color camera, you need a white light to see colors. Because if you don't have white light, the color camera doesn't see the color. And the infrared camera needs heat from any radiation to see the heat. And the same is if you go to the UV area, you need a fitting light source, ray source, which generates the right wavelengths that the camera can see or gets the response from these wavelengths. Finally, also the visible light is only a wavelength. The only difference is humans can see it, and because we can see it, we can more understand how the visible light cameras can work. Therefore, we have a short overview about the different light sources. And as I said before, if you want to you only have to decide, is the part red or green or yellow. You could use a gray camera and select a fitting color light source, because if you can generate the opposite reaction of your target color. Therefore, if you can select or switch between the different light source, you could work simply with the gray camera and a fitting light. Sometimes it's a cheaper solution or the faster solution. So, or you could use a white light and you use a fitting filter. If you only have to decide between two colors, would be also an option. So there are a lot of different options to make contrast. At the end, whatever we do with light and camera and the camera is generate a contrast. If it's a contrast in color or a contrast in gray or a contrast in infrared or UV or sphere, means sphere, it's always the same. You have wavelengths and you want to generate a contrast on which you can operate. And which is the best solution for this contrast? One have to discuss it. Sometimes it's very easy and sometimes it's more difficult. Here, of course, I didn't mention it so often. Also, X-ray are images, and at the end, these are gray images. So the software can also operate on X-ray. X-ray images is like a gray image. The only difference is the wavelength which is used to capture it, and the light source. Let's say light source is an X-ray source which generates the wavelengths for the sensor to capture it and operate on it. Or on the top, you see in this case, a colored thermal image. If you reduce the color, the wrong display color, this means red and blue, then we have a gray image where the white, or in that case, the white parts, in this case, the red parts, are the higher temperature, and the darker parts are the lower temperatures. And you can measure things in the thermal image, like you can measure things in the gray image, or you can measure things in the X-ray image, or you can measure it here in these filtered images where you operate on it. So for the software, it's important that you have the option to connect the right sensor to it and operate on these images. Either mostly, if you have a color image, it's an 8-bit or 12-bit representation. If you have a thermal image or an X-ray image, it's mostly 16-bit representation. And if you have a 3D image, you have a floating point XYZ representation of the numbers, which generate the 3D point cloud, or if you only have one line, the 3D profile on which you can operate. For the lighting technology, which fits to your needs, depends on your application. Once again, there are different standard applications where you can get standard light solutions. It's mostly the easiest way to do the illumination. First of all, you have to think, can I operate with a backlight? That means the light is opposite of the camera, or with a front light, and it's in the same direction of the camera. And in that case, if it's on the same side, can I operate an angle of the image so that I only illuminate what I want to see? Then I have a dark field or bright field illumination, or do I need more cloudy day as light? We have this ray of light presentation webinar, which you can have a look at it. There you see all the different light sources and how the light sources affect the surface of the image. So in many cases, if you have the right light source, you simply eliminate the need of special filters in the software. Even in some cases, software can't do it. Simply, I really recommend to have a look to all these different illuminations for the different applications, which really gives you a good insight what lighting situation will help you to get the best contrast for your task. Or, of course, feel free to contact us and we can give you either the presentation of this or give you a direct idea what kind of light would work. So these are simply the schematic overview of these light situations. And of course, you can buy ready-made light which either work directly or with some reflections or with some transmission. The light sources result then in these different images. So it's always the same part and only the light source differs. So you can see, of course, if you want to stable count or see if the two parts are here on the image, of course, if you go through all, you see in many cases some other stuff around it, which might be difficult for the software because maybe the PCB changes or the other parts are changing, and then it's not really stable. So if you use, for example, this bright field illumination, the background is dark, the part is bright, even if it's not so bright, but it's bright. So you are not disturbed by the background, and this will generate a stable application. Of course, nowadays, maybe you could use AI and you don't have to think so much about light, but it depends always what you want to do. And as I said, if you generate optimal signal based on the incoming ray of incoming data, it makes it easier for your application. So maybe you need only a blob tool in this case. You don't have to train something. You simply get that you have two parts here, and that's it. Instead of using the AI, train the parts maybe, or you have a ready-made trade and run it, then you need maybe some, to make it fast enough, you need a camera, a smart camera with the AI support. So in this case, you could use a cheap smart camera without AI support and it runs. So even today, it makes sense to think about maybe it's easier to use the right light to make a cheap solution at the end for the task. But one have to think what else have to be done on the application. Of course, finally, we discussed the lens a little bit. There are different kind of lenses. Most applications run with endocentric lenses. These are the cheapest lenses, and in many cases, they work very, very well. If you have to measure parts very precise and the parts are not really at a defined distance to the lens, a telecentric lens is always a very good solution, of course. Not mostly, unfortunately, telecentric lenses are not the cheapest lenses. Therefore, you have to think, do I need one? Is for the application a telecentric lens affordable or not? If you can afford it, or if the application can afford it, of course, telecentric lens is the best lens. Simply easy task, but because we see that, I would say at least 85% of all machine vision solutions run with an endocentric lens. It's clear why that most applications doesn't allow to use a telecentric lens. Therefore, if you have a special application and you have a price constraint, simply ask us and we can give you some ideas which lens would work for you perfect. There are also some special lenses like the hypercentric lens or Scheimpflug or an endoscope and some others. So we have a lot of experience and we can help you in selecting the best lens for your application. And what you have to determine before you start or before you ask, how far away is the camera or the lens from the part? How big is the part? What is what do I have to see, and so on. And if you give us this information, we can help you to select, or we can suggest you which lens would fit for your application. And finally, wherever you can get it for the application. As I said, and we can see it here, the majority of all the lenses, except for some line scan cameras, are with the C-mount attachment, so you can use the lenses directly with your camera you have selected. And of course, a last idea about filters. Filters eliminate some of the information in your image. That's what you can do also with filters in the software. But they eliminate it directly before it comes to the sensor, so you don't have to eliminate it. And you can get all kind of filters now, which fits to the needs you have. So you have simply to define, what do I want to do? For example, I have bottles with a red and a blue cap, and I want to distinguish between these. If you use a gray camera, red and yes? Okay. It was someone who told me something? No. Okay. You simply can eliminate these wavelengths, and then you have you can easily distinguish between red and blue or some other colors. So this is an option not to use a color camera. And finally, of course, at the end, you have to attach everything. So, and because it's not always clear, the distance and all other things, we really can recommend to have something really flexible. And so we have these EyeMount systems, which is based on dovetail. We really recommend it because it allows you really easy to adjust the height and the position, very precise. And because of the dovetail, you simply can attach it with these two screws. You can precisely position it and then screw it, and it's not moving while you are screwing it, which is important if you need a nice position for the camera. Of course, if you build your own machine, you will anyway plan to attach the camera in the right position. But simply what's important, keep you a little bit of space for some modifications at the end, because if you don't use a fixed mount, a fixed focus lens, which is made for you, you have some adjustment variation, and therefore it's always good if you not only can move, adjust it at the lens, if you also have the option to adjust the camera a little bit. So I see we just made a little bit more than our expected 1 hour, but finally, if you a few closing words. If you have any application, of course, I think you can test the software for your application. And if you have any questions about camera, lens, light, feel free to ask us before you start your application. Because it's much easier to select it before you bought it. And we can help you, or we're happy to help you to give you some ideas and to get your first experiences, how to make the solution and how easy and fast it is. I recommend that you can download the software. So we send you anyway the download links for the software and for the project files, so that you have an overview. And finally, of course, the image capturing system is still active. So if you download the software and you have either, you have anyway a camera from one of the manufacturers. You saw the list; it's really really large. Or if you don't have a machine vision camera, you have also the option to use any USB camera or the built-in webcam from your laptop or so. Of course, it's not for your final machine vision solution, but it's a nice thing to have real images to operate on real images. All the project files with the examples do have stored a lot of images that you see also how it works on different images, and how it's not simply optimized for this single image. You have always for each run, you get a new image for at this application so that you have a complete overview. Yes, so I think you have all our contact details. And for the moment, I think I could give you a short view to the software. Simply before I finish this application, I wanted to show you, for example, the list that you have an idea about the cameras. You see here, we have all these camera manufacturers, and if you use Windows and you don't have a smart vision camera, you could use the Microsoft Direct Show driver. You simply select it, and you then can use any connected USB camera to the system. If you have a Linux system, for example, this Raspberry Pi was the MIPI camera, you can select the video for Linux, and you capture images directly so that you really can operate direct on your examples. And after you have downloaded the examples, you have all these sample solutions. And therefore, if you have an application which you want to see, you simply open this project. And then in this case, you see here the application running. This is a ready-made solution. So, but you can change it also here. You have the same. So this is an example for a user interface. Not so nice, but it should only show how it works. And of course, you see also the configuration. So where you have the toolbox, which I showed you earlier, and you have the image. And if you have multiple cameras, of course, you can add here multiple images and so on. Here you see the application, which does this tools inspection. And of course, you have the toolbox, which you simply can use to your application. So you see here, this is also a demo version. This is exactly what you get. Only the I/O system is not active, but all the image capture stuff, also from the cameras, is working. You can select your target language if you don't want to have English. And so you simply can test the complete software by yourself. I really recommend that you have a short look to it. Yes. So finally, this is all what I have today. And now, if you have any questions, feel free to ask me now or send me a mail. You can see here the mail address, and we are happy to help you for your application, however you want to solve it. Yes. So if there are no questions, I would say thank you that you attended today's webinar today's and last webinar for 2025. And in this case, I wish you a Merry Christmas and a Happy New Year, and hopefully we see us next year. Thank you. And in this case, bye-bye.